This video is about the first type of functions we're going to look at in greater detail, linear functions. Okay, we've seen linear equations, right? So essentially replace the y by f of x, and then basically you get a rule. Since the values of f of x are essentially the y values of our points on the y-axis, graphing linear functions just like graphing equations such as y equals mx plus b. So nothing too different here. So essentially this is just a different view of lines in the plane using the concept of functions. So of course, m is still the slope here, b is still our y-intercept. Actually, it's the y-coordinate of the y-intercept. Okay, and we're just going to start with an example. So if I have the function f of x, remember this is not a product on the other side, right? It's f of x, so it tells me that x is going to be associated each time to twice its value plus 1, right? So in other words, if I have 3 there, it's going to be associated to 2 times 3 plus 1, so that would be 7. So this expression here, that's my f of 3, right? So notice it's not at all a multiplication of anything. How do I graph a line? Well, I can use the fact that I know what its y-intercept is, right? So it starts at, doesn't start anywhere, but it crosses the y-axis at 0, 1. And then it has a slope of 2. So a slope of 2 means if I go forward by 1, I go up by 2. So pretty clearly at 1, the output is 3. But I could do that also by replacing x by 1 in the function, f of 1, right? F of, well, if I put 1 here, f of 1 is going to be 2 times 1. Whoops. It's going to be 2 times 1 plus 1. Okay, so generally speaking, we never write down these arrows, right? We're just going to write some stuff like f of x is 2x plus 1. Then we could write f of 3 is 2 times 3 plus 1, which is 7. And finally, f of 1 is 2 times 1 plus 1, which is 3, right? But I just wanted to remind you that this notation here is just to tell you that this is the rule for the correspondence between x and its output. So with a line, once I have 2 points, right, I'm done, right? I can just link those 2 points with a line, and that's the graph of f. Let's look at another one. If I have f of x, which is a constant, f of x equals 4, what's the graph of that? Well, you remember, right? F of 0 is going to be 4, right? The output is always 4 for that kind of function. I don't know what happened there. F of 1 is 4, f of 2 is 4, f of minus pi, that's 4, right? It's 4 all the time. So basically it means that if I have f of 0 is 4, it means that 0, 4 is a point on the graph. This means that 1, 4 is a point on the graph. 2, 4 is a point on the graph. Minus pi 4 is a point on the graph. So essentially what these points share in common is that their y-coordinate is always 4. So always 4, which means that I have what we call a constant function. So this guy here, that would be 0, 4. So this is the line y equals 4, and this is the graph of f of x equals 4. So in general, right, if you've got f of x which is equal to some constant k, well, its graph is going to be like k all the time. So this would be 0k. This would be the line y equals k. Okay, so this is what we call the constant function. So this is a constant function. Okay. So that brings us to what? Like, what if I have a vertical line, right? Now we have horizontal lines are covered. Those are the graph of constant functions. What if I have a vertical line, and that would be a line of the form x equal, well, the equation would be x equals k. K would be some number, right? So this would be k0 right there. So x is always k. So this would be, I don't know, k1. You'd have k2. You'd have k minus 1, for instance. Okay. So essentially, if we look at this correspondence, right? If I look at the domain is basically k, just single value. The range, well, all the real numbers, right? I would cover all the values of y. So the range is r. So k is associated to, well, to minus 1. It's associated as well to 0, to 1, to 2, basically to all the real numbers all the real numbers. Notice all the numbers are there. I've started writing down integer values for y, but you also have like some non-integer values, some fractional or irrational numbers. So this is not a function, right? So you can see that arrows leave from k to reach out many points. So this is not a function. So essentially, vertical lines are not the graphs of functions. Not the graphs of function. And you can see that right away when you have a rule. If you can write y equals some expression with x only, right? You're going to have a single y for whatever value of x you replace it by. So this is going to be some f of x. Okay, so that's going to be a function. So the problem with x equals k is there's no y. I can't solve the equation for y. If you can solve the equation for y, it's going to be its graph is going to be that of a function. Similarly, if there are two points which have the same x values but different y values, that's not going to be the graph of a function. So I'll show you other cases where I don't have the graph of a function. So imagine you have something like this. Okay, if you can draw a vertical line anywhere, but here actually it works in many places, and it crosses the graph in two different points, okay, that's not going to be a function, because imagine this is I don't know, x equals 2. This would be 2 something. This would be 2 something else, right? That could be, I don't know, 2 4, and that could be 2 minus 5. So for a single value of x, let's say here 2, I have two values of y, 4 and minus 5. So if for a graph you can draw a vertical line that crosses the graph in two different points, it's not going to be the graph of a function. Okay, so that's called the vertical line test. So if the graph fails the vertical line test, it's not a function. Not a function. Okay. Let's look at another one here. I've got something that looks like this. Okay. If I draw a horizontal line anywhere, you can actually see that I'm intersecting this graph in only one point each time. Right? It intersects here only, here only, here only, here only, here only. So it is a function. Okay, it passes, right, the vertical line test. Maybe actually verifies is more appropriate here. Let me change that. Okay. Maybe a quick note. Okay, there's no such thing as the horizontal line test. Okay, so for a function, you could have something that's like that. Okay, you could actually, in your head, like if you take a vertical line, anywhere it's going to intersect the graph in only one place. Of course, if I draw a horizontal line, it will cross it in 3 different places, but that's okay, because that just means that for 3 different values of x, okay, it could be, I don't know, I'm just making that up, but it could be, I don't know, -2, 1, and 5. You have the same y value. So imagine that this line is y equals 4. They would both be associated to 4, but that's okay, right? Because essentially you'd have 2, 1, 5 as both all associated to 4, but that's okay. There's still only one arrow, one value of y associated to each value of x. So the horizontal line test is not a test that exists to determine if something's a function or not. Vertical line test is.